In this video, I'm going to take a look at the lesson and the examples all together as one, and we're going to look at geometric probability, as you see. Now, geometric probability is very similar to regular old probability, and we're going to look at it as a fraction, or that's how we'll calculate it, and we're going to look at it as favorable region over total region. Now, when I look at just probability, generally speaking, I look at what's the number of favorable outcomes divided by the number of total outcomes. So similar here, but it's just going to be talking about regions instead of outcomes. Now those regions could be lengths, they could be areas, they could be volumes, they could be degrees, many things, just dealing with a geometric aspect to it instead of the regular old probability. So I'm going to look at one example. And in this one I want to know what's the probability of a dart hitting my dartboard here that you see randomly. So it's basically saying I have no skill other than I know that when I throw my dart it's going to hit the board somewhere. So the probability of finding that green region. Now there's a couple different ways to do this. I'm going to go back to what I did the other day, and I had this exact same problem, but I asked us to find the area of the green sector. So what I can do is I can look at my probability in terms of area. So I'm going to say probability is going to equal, now my favorable region would be the area of the green region, which, going back to the other day, I calculated the area of that to be 75 pi over 8. So there was the area of the green region. And then we'd have to do the area of the total region, which would be the whole circle. Well, the area of the whole thing is going to be a circle, so pi times the radius squared, and the radius is 5 squared. So that would be 25 pi. If I put all this over here, I'm going to have my 25 pi in the denominator. I'm going to have 75 pi over 8 in the numerator. So I have a fraction within a fraction. Now, thinking about what this black fraction bar means, it actually means to divide. So I'm dividing by 25 pi. And what I'm going to do is I'm going to rewrite it as my 75 pi over 8. But then division is the same thing as inverse multiplication, so I'm going to multiply then by the reciprocal of 25 pi, which would be 1 over 25 pi. Now the reason I do that is because now I can do some simplifying. My pi's are going to divide out. The 25 is going to become a 1, the 75 is going to become a 3, and now I have some pretty easy multiplication. 3 times 1 in the numerator, 8 times 1 in the denominator. The probability of my random dart hitting the green section or green sector is going to be 3/8. So that's one way to calculate the area of that sector. Now there's another way that maybe some of you were looking at and you said, well, I can do this a lot faster. You don't always have to use the area. I look here and we know the measure of all the angles that create each sector. Well, I can go with my probability equaling my favorable region. Well, now if I look at it in terms of measures of the angles, that'd be 135. Divided by, now, the measure of all the angles, which is 360 degrees. There's my answer, other than I haven't simplified it. And what you find out when you simplify 135 over 360, it comes out to be 3/8. So there's another way to calculate the probability of landing in that shaded region. And just keep that in mind for whatever you do. To calculate the probability of landing in some spot, or probability geometric probability in any way, it's going to be that favorable region divided by the total region. Put it into a fraction format in most cases. Sometimes leave it as a fraction, sometimes punch it on your calculator and turn it into a decimal, and that'll be the extent of geometric probability.